What do you think, guys? You want to get started?
Go, sure.
Okay, great. Hello, everybody. Welcome to Passagemaker's Dockside chat on forward-looking 3D sonar technology. My name is Jeff Moser, and I'm editor-in-chief of Passagemaker magazine, the long-range cruising authority. So forward-looking sonar technology is still relatively unknown in the cruiser yacht, trawler yacht market, but like many advanced navigation tools, it's made our way to our community after operating in the commercial, military, expedition cruise ship, and the mega yacht markets. And over the years, these products have become simpler to use, smaller and lower cost. And I'm excited to see how this technology is becoming a good match for our community, which I think it is. And today, I'm joined by Bob Arrington and Matt Zimmerman. Many of you in our audience know Bob as an active member of the trawler community. His expansive list of articles on seamanship and boating lifestyle have been published in a range of magazines. He's a longtime Trawler Fest instructor, providing boat owners with lessons in seamanship, safety systems, handling, and vessel operation. And he's a regular contributor to various online forums. Bob loves to discuss interesting topics related to cruising adventures, and he loves to share his wealth of knowledge with everyone. And the next gentleman is Matt Zimmerman. Matt is the founder of FarSounder, the developer and manufacturer of the world's leading 3D forward-looking sonar. Matt and his team created the only commercial available forward-looking sonar capable of generating a complete 3D image with a simple ping out of navigationally significant ranges. Gentlemen, I'm excited that both of you are here today.
Jeff, thank you. I've been looking forward to this talk today. I think this type of forward-looking sonar technology is going to be a welcome addition to the helm of a lot of cruising boats. You know, it seems pretty cutting edge, but a lot of the cutting edge technology that was years ago, even AIS or night vision cameras that were rare on boats years ago, except maybe sophisticated cruising boats, they've now become commonplace on cruising yachts, and people couldn't imagine going out without that kind of equipment today. And I think this type of equipment is going to be the same. Now, as high quality production trawlers are enticing owners to cruise into more remote places, I can see this technology becoming as commonplace as your radar today.
Agree with you. Thank you. So I know like the most basic types of sonar is like an echo sounder or a fish finder, which looks directly down and tells you how deep the water is below the boat that you just, the water you just drove over. But what's really more important is what's in front of you and where you're going, not where you've been.
You know, that's right, Jeff. What a boater really needs to know is where the rocks, the corals, and the unseen submerged objects are in front of them. It would be nice if we could just take our current sonar and point it forward, but unfortunately, the technology doesn't work that way.
Yeah, and what Matt had told me earlier, this is probably one of the impetus of the reasons that he founded FarSounder. And he's going to help us understand this. His technical expertise are really going to be greatly appreciated, and to me and our audience, understanding both the broader picture of how this works and the detailed nuances of what 3D forward-looking sonar means and how it can benefit our trawler and yachting community.
Thanks, Jeff. Thanks, Bob. So I helped found FarSounder over 20 years ago, and solving the problems that you just mentioned are exactly what we set out to do. Our original motivation was, how can we reduce our environmental impact out on the water? We're located here in the Northeast of the United States, and we have some experience with oil spills and endangered whales. So we really wanted to help develop a technology. How do we avoid hitting rocks, causing oil spills? And how do we avoid hitting whales, killing these endangered animals? So the company was founded in 2001, and we started shipping our first products in 2005 with our legacy FS3 and FS3DT products. Those products were really focused on the expedition cruise ships and large super yachts, but they led to the development of what's our current product line, the Argo series navigation sonars. And we have models operating ahead of the vessel out to 1,000 meters range. That's over a half a nautical mile ahead of the boat. And since launching the Argos 350 2 years ago, we've really focused on expanding our markets. And one of these new markets that we focused on is the cruiser and trawler yacht market.
Great. I'm surely going to have a lot of questions for you too that I'm looking forward to hearing the answers on. And Bob, I'm sure with all the cruising you've done, you're going to have some great insight about how this 3D forward-looking sonar can increase safety for cruisers and your experience over the years where you maybe wish you had this type of technology on board your boat.
Well, it's true. And I almost equate this to watch keeping, which is one of the most important roles that a captain or a crew member can have on a boat. It doesn't matter what kind of boat it is. Knowing what's in front of and around you is critical to being safe. Well, this includes watching what's in front of us underneath our boats as well. It's just that the technology hasn't existed for recreational cruisers like us to be able to do that. Many of the groundings that have occurred could be prevented by our ability to know what's under the water in front of us.
Yeah, I'm sure of it. And for everyone in the audience, please feel free any time during this seminar to ask questions via the side panels. They come up, and I'm going to keep an eye on that. We will have a Q&A at the end of the discussion, but if I see something that's relevant to what we're talking about, I'm going to try to bring that conversation into the real-time talk. So let's get into it. I'm going to start by asking the most basic question. What is forward-looking 3D sonar?
That's a great question, Jeff. So first of all, a sonar is anything that uses a sound wave for a measurement. And any sonar that points forward could technically be called a forward-looking sonar. There are lots of sonar products on the market. As you mentioned, the most common one is your down-looking echo sounder or fish finder. And that gives you a single point directly below the boat that you just drove over. And if you were to drive the vessel somewhere and connect all those dots together, you could build a 3D picture of where you've been. So I guess technically you could call that a 3D sonar. And if you look at traditional survey sonars that look straight down, these are 2D multi-beams that again build a picture of where you've been and can build a 3D history. Again, all the places you've been. From my point of view, a forward-looking 3D sonar is really what boaters and trawler operators really want to know from a navigation point of view, which is building a 3D picture in front of the boat before you get there. So you have not just a 3D history, but in my mind, the real important information, which is the 3D in front of you. Where are the rocks, where are the whales, where are the corals, the things that you don't want to hit with your boat.
Yeah, it is so true. And when we look at our charts, we talk about the bottom conditions, regardless of the format we're using, they seem full of detail. Bottom contours and depth soundings are represented pretty clearly, but a lot of this information is quite old. I mean, some of it could literally be hundreds of years old. And if we see 50-foot soundings on our chart, they may be spaced out. And we assume if there are multiple 50-foot soundings on a chart underneath us, that it's 50 feet everywhere. But unfortunately, that may not be the case. And I mean, even the Navy has run submarines into seamounts that no one knew existed. So we take a lot for granted and we make a lot of assumptions, even in the very detailed charts that we use today. So this added information of what's in front of us is really going to complete that picture.
You've kind of answered my next question partly. We have digital charts, GPS, satellite imagery, and you figure, are we covered for the most part? But from what I'm hearing, we may not be.
Yeah, Jeff, I think that's totally true. With a forward-looking sonar, you really want, well, not with the forward-looking sonar, but any vessel operator really wants to know what is not on the charts. And that's what a forward-looking sonar can do. You have your radar, you have your cameras looking above the water because the charts aren't sufficient to solve all that information. And looking below the water, you can have a 3D forward-looking sonar. So, think about what large ships do. When they go into a port, they generally have a local pilot on board. And, certainly some ports, that's just a local tax on these big ships coming in. But in a lot of places, those local pilots are really required from the navigation point of view. And the reason is the full picture isn't captured on the chart. And the local pilot's knowledge is necessary to bring these ships into port. So when you're out exploring on your trawler, you're probably not a commercial operator. You probably don't have a pilot on board. How confident are you in what's out there? Why do you have your radar installed? Why do you have night vision? Why are you looking at AIS? Because the chart doesn't solve the whole problem and provide the complete picture. So what we hope to do, what FarSounder does with 3D forward-looking sonar, is help fill in the missing pieces to that picture, working in conjunction with the radar, cameras, charts, and so forth.
Matt, boaters have become comfortable with how all of this other technology is presented on our helms. We're comfortable with our radar or even night vision. How does this new technology show up at our helm? Do you have a dedicated screen that we're going to see this information, or is it going to be broadcast on our current MFDs?
That's a great question. So the FarSounder system, our user interface runs on a computer, and we can talk more about those details later, but suffice it to say, we have a video output. So that can go into a video input on your MFD or on a dedicated monitor. And this picture I'm showing here, this video, is what our 3D sonar looks like. So that pie wedge is everything in front of the vessel in 3D, colors mapped to depth. And then that trail behind you is that 3D history of where you've been. Let me zoom in or zoom out and look at the entire user interface. This is what our full software looks like. So we have the 3D sonar view that I just hinted at above on the left. Below that is a 2D profile, which is actually the depth along that white plane in the center of the 3D view. And you can move that back and forth to look at different angles. And that whole 3D image is overlaid on top of the chart, which you see on monitor.
Mm-hmm. Great. Great. So I can see that the products have a simple, intuitive user interface, which displays not only the sonar data ahead of the vessel, but local history mapping, data, and a 3D history of where the vessel has been. Now, are there any specific examples of applications that are relevant to, say, coastal cruisers, ICW, passage makers?
Well, I can give some just from the summer. We're on our boat right now, moored in a harbor off of Buzzards Bay. But we spent the summer up in Maine, and there's a chart up right now that is part of our route that was just a couple of weeks ago. We left Mount Desert Isle, and we were cruising north of Swans Island, and then back down toward the opening of Penobscot Bay. And it's not uncommon up there that your chart take you through islets and reefs that could be completely awash at high tide, and very shallow areas. The area up there is so full of these islands and islets. It's part of the beauty. You want to go cruising through these, but you are really counting on the accuracy of those charts to know how close you can get. We've got a highlighted box here in between red 4 and green 5 there. We've only got a couple of feet on either side of us, and it's only a couple of 100 feet across between those two markers. Yeah. So, and the other thing about Maine is it's full of lobster pots, and so you don't know where those are going to be, and you don't know when a lobsterman's going to be coming in and working those pots. So you can't always stay on your intended course. I mean, I laid that route out right in the middle of those two markers, but what if I have to go around one of those lobstermen or around a series of pots? I'm really counting on knowing that edge, that bottom contour is coming up to 4 feet deep, exactly where it's charted. I don't know that I can count on that, so we give it as wide of a margin as we can. But wow, wouldn't it be great if I could literally see those bottom contours in front of the boat as we're approaching? And now I know how close I can get to that port side as we're passing by. It's just one example of many that I could give. We were in the Bahamas not long ago, and we were in West End, and we were going to go around into the Abacos, and we need to cross a little Bahama bank there. Most good-sized boats would go up to Memory Rock and across, but I got word of a couple of GPS points that someone had given us that where we could cross the bank before going up to Memory Rock. Looking at the Admiralty charts that we use for the Bahamas, it very clearly said area not surveyed. And so we really were flying blind to go across that. If I counted on this person's waypoints, he said, take a straight line between these and it'll be great. And you'll have plenty of depth there. Wouldn't it have been nice to have been able to see the coral heads that are so common across that area as we're cruising through there? It's one of, again, a lot of examples. We were up in Nova Scotia not long ago, and we were with several cruisers on moderate sized cruising boats. And ours is a 54-foot boat. We had friends that were up there on comparable boats, and they said, well, we're going to take a couple of weeks and go up to Newfoundland. Well, now all of a sudden you're getting into areas of ice, potentially even in the summertime. And to be able to see that below the water. We have friends that are in Europe right now aboard their boat. They crossed over from Florida into the Mediterranean, and they're going to be coming back via Greenland, Iceland, and a northern route. This technology could make that a much, much safer trip.
Yeah, ice, coral, rocks, those are great sonar targets. You talked about cruising in the Bahamas, and, the main transit lanes are fairly well known, but then when you want to go off, have lunch or go snorkeling in that cove over there into that small bay, you don't always know. The charts might just say reef over there, and a forward-looking sonar can really help you get in there. So passing through a barrier reef is a great example of how a forward-looking sonar 3D imaging ahead of you can really help. And I have a couple of real data sets from some of our customers in testing that I'm showing here right now. And with the chart overlay, you can very quickly see where the 3D forward-looking sonar sees things. And if it matches the chart, you can have a high confidence in your chart data. But where it doesn't match the chart, those are exactly the places where you really want to pay attention. So, Bob, you probably have experienced making your way in through a barrier reef. You might post someone on the bow to try and look through the water when it's clear to see where are the corals. And of course, you have your GPS track to try and follow it out on the way back. But I'm sure that sometimes you've gotten a little too close for comfort on that track. And the sun has to be in just the right angle for you to be able to see through the water. What do you do at night? What do you do in the fog? What do you do when you do want to not follow your GPS track because you did get too close, or the tides have changed, or the wind is now blowing from a different direction and you're fighting against the wind? It's really nice to have not only the real-time display, but that 3D survey of where you've been making your way in on the way out. Another great application while you're cruising around is, where are you going to anchor? As you know, in a lot of developed ports, there are specific anchorages, but a lot of the places where you're cruising, there are no official anchoraging points. And you just look on the chart for some place that might be protected from the wind. Hopefully, in the lee, so you don't have too much wave action as you're on anchor. And hopefully someplace that looks like it's big enough and wide enough that you're not going to end up on a hazard. On the right-hand side of this picture here, you can see the boat is doing a quick anchor survey. After completing the survey, you can anchor in the middle of your surveyed location. And then as the vessel is swaying with the wind and the tides and the currents, you can see where your stern is relative to any of those shallows that you may have surveyed. So yes, there's real-time applications, but also this historic data that you're essentially building your own survey can add a lot of value to your cruising itineraries.
I can see that. Besides the bottom contours, Matt, we talked about being able to see ice or being able to see objects under the water. Is there a limit to the size or the shape of objects that show up in this technology?
That's a great question. Generally, our sonars are able to see the types of hazards that you don't want to hit with your boats. Shipping containers, icebergs, coral heads, rocky reefs, and other unknown things. Think about how many old piers have you come across where the pilings are sticking up to like just the surface of the water, or something that is exposed at low tide, but totally hidden at high tide. Those are the types of things that our sonars see well. Other examples are things that change seasonally. If you're cruising through Alaska, there are some tight passages with high currents, and large boulders get moved around. And when there is a winter ice, those will sometimes push new boulders and debris. So even if you came through a specific passage last season, it might not be safe this season. And having a real-time view ahead of you can really help get through there. Post-disaster, another example. After Hurricane Katrina, there were a lot of oil rigs in the Gulf of Mexico that were lost. And when I say lost, I don't mean that they were broken and damaged, needed to be replaced, because yes, they did, but literally lost. We had some oil service companies contact us and say, hey, how quickly can we get a sonar? Because we're bringing out a new oil rig and we don't know where the old one is, and we don't want to hit it as we're bringing out the new rig. After the earthquake in Haiti, the international community had a ton of relief supplies on ships days after the disaster. Couldn't bring them into shore because they had no idea what the port facility was like. They knew before the earthquake, but not after the earthquake. Were there debris in the water, cars, containers that fell off the docks? Who knows? And they ended up spending days shuttling supplies in by helicopter rather than being able to come right into the port until they were able to complete an official survey. And even shipwrecks. Shipwrecks can move. We did some testing out of Panama City, Florida, and we were looking at things in about 100 feet of water, a big pile of stuff off the seafloor. So we chartered a boat from a dive operator, and they said, great, we'll take you to shipwrecks. And they brought us to a bunch of known shipwrecks in about 100 feet of water. And we passed over a known wreck, and about 300 or 400 yards after that, we saw another big blip on the sonar. The dive operator didn't know anything about it. When we came back to shore, we found an old timer and told him about what we found. And he said, oh yeah, that was a shipwreck that moved during the such and such storm, and that's where it's now located. So it's amazing, the force of nature. And even if you used to have a good chart, you can't always guarantee what's there.
It is amazing what can happen. We regularly dive off the coast of North Carolina, and there's an artificial reef, Aeolus, that was sank there. It is a almost 400-foot long. It was a cable layer. A hurricane broke that ship in two, and it's in 100 feet of water. So it is amazing how the bottom can change with weather like that.
Yeah, I actually dove on that earlier this year. It's a great shipwreck, but that's a known shipwreck diving location. Our sonars, FarSounder sonars, are looking forward, but they also look down to about 85 meters. So that's way deeper than recreational diving. It's even deeper than, entry-level technical diving. So if you wanted to go find that new coral reef or that atoll or someplace that no one else has ever dove on, you want to be able to look down and see those features. From a navigation point of view, charts really don't give any detail, even in well-surveyed areas, once it gets deep enough to safely transit, because you're not worried about hitting something that is 100 feet underwater. But as a scuba diver, you want to see where that thing is, because you want to land on top of it and, explore the shipwreck, see the coral reef, see the fish, and so forth.
Exactly.
Hey guys, I've got some interesting questions from the people in the seminar. I want to go back to a few of these. Steve had asked, are the charts integrated into Argo system, or do they leverage charts on the existing MFD? And I just want to roll that into another question where someone asked, can you record your tracks and build a database? And then another person, this is interesting. They said, now is that data shareable with a service like Navionics for, the importance of improving charts in the future?
Those are all great questions. I'm going to pull that picture, those videos I shared up on the screen again so I can talk about those answers.
Thank you.
What you see here is FarSounder's software, and the charts that we display are in the standard S57, S63 format. If you're operating in US waters, you can download all the US charts for free from NOAA. When you're operating elsewhere in the world, you can download and purchase them from various chart suppliers. We're not an ECDIS, so these are not official charts, and you don't need to have a subscription with weekly updates to stay in compliance because we're just a non-official ECS here. A lot of the chart plotters and MFDs that you're using on your boats support these standard formats. These are formats governed by the IHO globally. And if you're using these standard formats in your MFD, you can use them inside our software as well. If you're using a proprietary format for the chart data coming from your chart plotter vendor, unfortunately, you're not going to be able to use those same charts, but probably your chart plotter supports these standard chart formats as well.
But just to be clear on that, Matt, so what, if I'm hearing you correctly, this image of your sonar is not going to be overlaid onto the existing boater's chart on his MFD.
Correct. Correct. This is our software, but as a video input to the MFD, you can display what you're seeing here. As far as the recording of that history, we support an unlimited recording duration in our software. Obviously, you're limited only by your hard drive space, but Bob, you've been underway for the past couple months, pretty much all summer, starting from Florida all the way up to Maine, and you're starting to make your way back. Standard hard drive size, that's going to capture your entire trip, no problem, wow, inside the software. So it has a real long memory. In our software today, all of that stays inside your local machine. But obviously, the next step is what can we do to bring it off the vessel to share across your fleet of friends or share with the wider community. And that is obviously features we're going to be adding through software in the future. However, currently, outside of our current standard software, we do have what we call our expedition-sourced ocean data collection program, where customers can opt in to participate, and we actually send them a USB hard drive to plug in, and it will record all the raw data from their sonar and NMEA sensors as they're underway. When the drive is full, send it back to us, we compile it, and with their permission, we can actually submit a subset of that data to NOAA as part of the IHO's DCDB, Data Center for Digital Bathymetry. FarSounder is part of the IHO's crowdsourced bathymetry working group, and this is a group composed of all of the hydrographic offices around the world that are part of the IHO, and industry and academia, trying to develop ways to collect data globally and share that as a community. And all the data that's recorded is available publicly for free from the NOAA and IHO's website. And this is a technology that's still pretty nascent, but it is, everything that's recorded also gets submitted to Seabed 2030, which is a global initiative from JEBCO and the Nippon Foundation to try to build a map of the world's oceans by 2030. But a map of the world's oceans from their point of view is not every detail. It is one depth point every 100 meters. That is their goal. And they know they will never get there by 2030 because there is such a vast amount of the world's oceans unmapped. But that's the incentive initiative. So anyone that participates in our data collection endeavor, with their permission, we can submit data to the IHO, which is part of the Seabed 2030 campaign, and all of that is free for use by the public. A couple of exciting things happening with that. We have cruise ship customers who are recording drives as they're going through the Northwest Passage and down to Antarctica, collecting recordings and building maps of places that no one's ever built maps of before, which is pretty exciting. And the Canadian Hydrographic Service is actually trying to expand their initiative to use data collected from trusted sources, but not by official surveys on their charts. And there is a recently updated Canadian Hydrographic Service chart that includes data recorded by a FarSounder customer during their Northwest Passage expedition. So the short answer is today everything stays on the vessel, but it's as much space as you would possibly need. We have some sort of scientific endeavors to collect data on a hard drive that's available today to select customers. And in the future, we envision being able to share this across a fleet and globally to really get a lot more knowledge and information about our oceans.
Boy, Matt, there's so much information here, and it's going to be real exciting to see how this is integrated into cruising yachts like ours. Is it easy for the common boater to understand how to use this? Will we be able to adapt to this pretty quickly?
That's a great question. We've really focused on making FarSounder's products and user interface easy to use and easy to understand. All those videos that I've been sharing with the group so far, that's real data from real FarSounder systems. And I hope they could see that it is pretty easy to use. We have color mapped depth, where blue and deep is deep and yellow shallow. We have user definable alarm. The user can define how far away, how wide a sector, how deep, and sensitivity. And when anything shows up inside that alarm volume, the screen blinks. If you have audio, there's an audible alarm. There's very few controls because we want this to be easy to use while you're operating your vessel underway. But like any other technology you have on board, like your radar, like your camera, like your chart plotter, you want to make sure that you're using it in times when you don't need it, so you become comfortable and able to use it at times when you do. We also offer a complimentary online end user training program. It's accessible through our website at farsounder.com. It's open to anybody. It's about a 4-hour class that has video on demand and then short excerpts. And I've spoken to a lot of current and future customers that have gone through the training program, and the feedback has been overwhelmingly positive. I'm really proud of my team having put this together, and it's a great resource to learn how to use the sonar for customers that have a FarSounder Forward Looking Sonar installed, but it's also a great opportunity to see exactly what the system does. So you understand what it can do, and more importantly, what it can't do. So for boaters that are thinking about a FarSounder, I would recommend signing up for the class, take a look, learn more, and you'll have a really, really clear picture of what to expect if you are to install an Argos series sonar.
You know, this gives us a pretty good idea of how all of this comes into our helm. Can you tell us a little bit about what the hardware looks like? How is it installed in our boats?
Sure. Another great question. So we have 3 models. They are the Argos 350, Argos 500, and Argos 1000 that I'm showing here on the left. Cleverly named because they go 350 meters, 500 meters, or 1,000 meters respectively in range. I think a lot of boaters in this trawler yacht market are probably interested in the Argos 350. So that's 350 meters ahead. That's over 1,100 feet forward of the vessel that it can see with a single ping. But of course, we do have trawler yachts with Argos 500s and Argos 1000s installed. The transducer module, which is the part that goes in the water that we see on the left, that's generally installed on the bow as far forward and as far deep as possible. There's no moving parts. It's all solid state. and they all connect to the same inboard piece of equipment, which we call the power module. It's a black box, or white or gray box technically, and that connects to a custom cable with an underwater wet mateable connector. And all of those go to the same software that we've been showing so far earlier in the discussion. All the products are essentially the same, and their differentiators are primarily the range, field of view, and maximum operating speed. So the Argos 350 is good to 350 meters range with a 90-degree field of view. So that's over 1,100 feet ahead. And it's suitable for operations up to 18 knots. Argos 500 goes out 500 meters range over a quarter nautical mile, and the Argos 1000 goes over 1,000 meters, which is over a half a nautical mile. The vast majority of our customers use a fixed mount installation, which uses a fairing, which is essentially a tube that gets integrated into the hull. And here's a sketch of the Argos 350 and Argos 500 installation concepts. Whether it's a circular tube or a rectangular tube, you integrate that into the hull, and then the sonar goes into the opening of that fairing from the exterior. And what this looks like on a real vessels are things like this. This is a 62-foot Nordhaven with an Argos 500 installed on a pretty small bulb. Here's a slightly larger bulb with an Argos 350 installed there. But you don't have to be on a bulb this bow in order to install our equipment. The Argos 350 or any of our products can be installed on raked bows, whether they're steep or slightly raked. Here's a picture of a 72-foot Princess that installed a FarSounder during a refit last year. And you can see the fairing added to the bottom of the hull, and the transducer fills that front hole in that fairing once it's installed. We do about 50% refits and about 50% new builds, so it's really easy to install the system. I mentioned the end user training. We also have a technician training class that all of our dealers have their technicians go through. Again, that class is also available to customers if they want to get into all the nitty-gritty, and it talks a lot about the installation design. We have a complete installation design guide, and of course, sample drawings on how to integrate this directly into the hull. Here's yet another example of an Argos 500 on a trawler yacht, and we can see there's the fairing. In this case, they actually installed it on the side of the stem because they didn't want to cut the structural member on the leading edge of the stem. All of these are fixed mount installations, and most of our customers install it in that manner. But of course, there are some customers that want to install on a hoist, so it actually gets deployed down below the hull, and then it can be retracted when you don't want to use the sonar. In this case, the Argos 350 can be ordered with its connector on top to facilitate attaching it to a hoist. Some of our customers are like small, high-speed vessels that want to go up on plane, go really fast when they're in places they have high confidence in. But then when they're navigating into the shallows, they're obviously not going at full speed. They're back in displacement mode, and they can deploy the sonar on a hoist. We have a partner in Denmark, C4R, which makes hoists specific for the Argos 350. But of course, with an adapter plate, you could connect to any off-the-shelf hoist. The Argos 350 is designed for a 10-inch diameter sea chest. So if you have a sea chest already installed, you could replace whatever in there with an Argos 350 on a hoist. And in this example here, you could even attach a cowling to the bottom so that when it's retracted, it is flush to the hull like we see here. So lots of different options for every type of hull shape.
You know, Matt, it looks like this is integrated into the boat quite seamlessly in many applications. A few questions about some of the other technical aspects of it. How is this powered? Is it DC power or AC power? And if it's AC, can it run off of an inverter?
Yeah, some more great questions about how to actually get this on board. Our equipment is AC powered. The Argos 350 draws about 50 watts plus the computer, so that's really easy to put on an inverter. Of course, we're looking at options in the future for potential DC operations, but today these are AC powered products.
All right. Are there any depth limitations? How far down? We talked about how far forward it will go, and I understand we're only concerned with things that we may encounter. But what are the depth limitations of the unit?
Again, great questions. As you correctly pointed out, one of the most fundamental questions is how far forward can you see? And I think we talked about that quite a bit. But when you talk about range, there's actually two parts to the range question. One, which is how far can you see at all? And then how far can you actually build that 3D map ahead? Maximum range is just a function of the hardware, but the 3D bottom mapping range is a function of how deep the water is below the transducer. FarSounder 3D forward-looking sonars can map the seafloor in 3D out to at least 8 times the depth below the transducer. But even beyond that, we can see all of those obstacles and targets ahead. The reason for this is a limit of physics, and I put together a couple of pictures that hopefully illustrate where this limit comes from. So think about your echo sounder. All your energy goes straight down and nearly all of it comes back up like we see in this picture here. But if you are to push that echo sounder forward, pushing your energy out forward, on a steep angle, most of it comes back, but a little bit reflects off the seafloor, reflecting forward. At a shallower angle, the seafloor is still reflecting, but less reflects back to you and more reflects forward, until at some point, the seafloor is reflecting, but it's reflecting all of your energy forward. You can think of this like shining a flashlight on a mirror. The seafloor is the mirror, the sonar is your flashlight. If you're lined up pretty perpendicular to that mirror, it's going to reflect the light back to you. But at some point, when you're at a shallow enough angle, the mirror is going to reflect the light, just not back to you. And it turns out with the sonar and the seafloor, this limit is about 8 to 1. So 8 times forward, the depth below the sonar is roughly where the seafloor starts to reflect all of the energy forwards. Of course, it varies with the bottom composition. And if you look at the videos and screenshots on our website, most of them are not 8 water depths. They're showing you 10 or 12 water depths. We really like to under-promise and over-deliver. So this is a limit of physics that any type of acoustic sonar system is going to experience when facing forward. And it's about 8 times the depth below the transducer. However, beyond that bottom mapping range, we can still see things, even in shallow water. And how we do that is real simple. If you think about now a rock or coral or some other hazard on the seafloor, beyond your bottom mapping range, instead of reflecting forward, once you have that structure, you now have something that can reflect back to you. And how that looks in reality is what we see on the screen. On the left, we see the 3D sonar picture. Everything inside that pie wedge is real time ahead of the vessel, with the history coming towards the bottom of the screen. And in this example, we see a hard sea floor. The sonar is mapping the bottom about 10 water depth, so better than what we specify. And we can see a number of in-water targets. And by looking at the chart overlay, you can see that those targets clearly correlate to the bridge, and those are actually bridge pilings from the Newport Bridge here in Rhode Island. The closest bridge pilings are within our bottom mapping range, and so they're rendered with color map to depth, where blue is deep and yellow is shallow. And those targets beyond the bottom mapping range are colored with color map to signal level, where dark orange is a quieter reflector and a light yellow is a louder reflector. We can't quite tell you how deep those long range targets are, because once the seafloor starts reflecting your energy forward, you're now bouncing these sound waves off the seafloor, maybe off the sea surface, maybe both, more than once. And this region is actually called the multipath domain. And we don't know how the sound propagates specifically, so we can't unwrap all of these echoes. That's not exactly true. If we knew all the water's physical characteristics, the math is easy to unwrap all of that. But we want to look ahead, so we can't make those measurements before we get there. So in practice, we don't know what's happening in the multipath domain. But when we have obstacles like the bridge pilings, like the corals, like the rocks, the ice, beyond that bottom mapping range, we can still see them as in-water targets with the range and the bearing and how loud the reflector they are. And again, how this looks in the real world is shown here. This is one of our Argos 1000s. We can see the shoreline at 1,000 meters away, so more than a half a nautical mile. Also simultaneously mapping the seafloor to about 10 water depths here, and including that 3D history of everywhere that we've been over. So this clearly shows correlation between what the sonar sees and the chart sees, with nothing unexpected between you and the shoreline. But if there was a big blip before the shoreline, you would want to pay attention to that. Chances are you're not going to be headed directly into some giant thing that's not on the chart, but there might be a pinnacle or a coral head or a transient object like a shipping container or ice. You want to know where those are so you don't inadvertently turn into them as you're navigating along your route. So your question about range is really two parts: the maximum range and the bottom mapping range. However, besides range, there's a couple of other metrics that I think are really important when it comes to evaluating different sonar technologies. One obvious component is the field of view. How wide can you see and how deep? So obviously the wider your field of view and the deeper down you can look, the more information you have about where you're navigating. A second component to field of view is what angle down do you look? So our products are very different than other products that call themselves forward-looking sonars. The vast majority of those are very simple systems, generally a 2D system producing just a single slice ahead of the vessel. And they don't have a wide field of view because they're just a single vertical slice. There used to be a product called Interface, and they made a 2D forward-looking sonar, and their website said, if you want to look in a different direction, simply turn your boat to a different direction. That's not going to cut it when you're trying to navigate through these types of hazards that you're concerned about. So having a wide field of view is really important, but also having a field of view that covers the full water column. A lot of these inexpensive 2D systems are actually designed to be installed looking down about 20 degrees and to be installed on the bottom of the hull. So for those systems, the field of view is kind of illustrated by what I'm showing here. By definition, they will never see anything that you will hit. They will only see things deeper than what you would hit. Probably they would have some sort of trend that you could probably try to follow. But to be a really effective forward-looking system, you really want a sensor that not only has a wide horizontal field of view, but a wide vertical field of view. FarSounder's Argos series sonars are designed to be installed on the bow, like I just spoke about. And these systems actually look up about 10 degrees to reach the sea surface and look down about 50 degrees until they reach the sea floor. So understanding what field of view is provided by a specific product is certainly important in understanding how effective it will be. And then the last metric I want to just briefly bring up is update rate. FarSounder's forward-looking sonars build that entire 3D image with a single ping, and sound waves travel pretty slow in water. The speed of sound in water is about 1,500 meters per second, and at 500 meters range, we can build that entire image in less than a second. But if you were to look at a mechanically scanning sonar to build the same field of view with the same number of horizontal angles, that could take up to 90 seconds per image. That might be fine for building pretty pictures, but is not, in my opinion, suitable for navigation. By the time you've been underway for a minute and a half, your environment has changed dramatically. So I think it's really important to have a solution that has a fast update rate when you're looking at potential different options for your forward-looking sensors.
Well, I can see that. Are there any frequency incompatibilities between existing sonar and the frequency under which you operate?
Another great question. We operate at about 61 kilohertz. As you probably know, the most common echo sounder frequencies are 50 kilohertz and 200 kilohertz. So we're not interfering with the equipment that you already have installed on board. And we chose this frequency for some important reasons. One, we didn't want to interfere with other systems. But two, as I mentioned earlier in the discussion, our early motivations are environmental based. And one of these strong motivations was how could we avoid hitting whales? Where we live in Rhode Island is the home of North Atlantic right whales. There's about 100 left of those off the northeast coast of the US. Sorry, about 300 left of those. Yeah. And they generally don't die until they're hit by a ship or a boat. So we obviously were interested in developing a technology that could avoid hitting whales. And at the same time, we didn't want to introduce a new problem that could be detrimental to the marine life. And 61 kilohertz is outside of the herring range of the great whales. And we actually had our equipment evaluated by NOAA's National Marine Fisheries Service. They evaluated our legacy product, which operates in the same frequency ranges, and they stated in writing that there's no impact to the marine ecosystem. We are quieter than a dolphin, so their own biological sonars are louder than what we do. We put in less energy than a commercial echo sounder into the water, and we operate at a slightly higher frequency than these most standard 50 kilohertz echo sounders. Acoustically, the higher the frequency, the quicker the sound dissipates, so the less potential impact you could have. So we've really focused on being more benign than everything else that's already commonly accepted.
Oh, that's great to hear. Jeff, as we're approaching the end of our time here, are there any other questions in the chat room or that we might want to be able to answer?
Bob, a lot of people are asking about the installation process. So, if they are interested in this product, how do they go about it? Is there a dealer network and they want to know about costs? So those kind of things, certified technicians, those are the kind of things that seem to be coming up a bunch in the Q&A. So I'd like to, if you could touch on that, Matt, that'd be great.
Sure. We sell our systems through a global dealer network in the US, Europe, Asia, Middle East, anywhere you're going, there's probably a FarSounder dealer there. Our dealers have certified technicians, so you would purchase a FarSounder through our dealer network. They would have a certified technician that would do work with you in the boatyard to physically install it and then commission and set up the system. The Argos 350, which is probably the target product for many of the people in this discussion today, has a list price of about 56,000 US. Obviously, that's plus installation and so forth. Yeah, we're a lot more expensive than some of the other products that call themselves forward-looking sonars. But I think once you dig into the capabilities of a FarSounder system versus another forward-looking sonar system, for the types of vessels and operators and uses that we are matched well with, those are really suitable for FarSounder systems and not suitable for the other products. And likewise, the target audience for those smaller, lower end products are really not suitable for the FarSounder system. So we don't really see ourselves as competing with them. We see them as two different levels of this type of technology.
Yeah.
It's understandable. Matt, will you be at any of the boat shows coming up during the fall and winter season?
Yeah, we have a lot of boat show visitations, dealers, and booths and so forth. We will have FarSounder personnel at the Newport boat show that's coming up quite shortly. We're going to have a bunch of dealers at the Fort Lauderdale International Boat Show with their own booths. FarSounder will be down there visiting our dealers, working in and out of our dealers' booths. For those of you that might be heading over to Europe, I'll be at the Monaco Yacht Show at the end of the month, and then we'll have another FarSounder booth at the Metz Trade Show in Amsterdam later this year. So we try to cover a lot of ground. Oh, we'll also have FarSounder personnel at IBEX at the end of September as well. So we can't be everywhere, but we try to be a lot of places, and we also rely on our dealer network to be that front line for the sales process. But any potential customer with questions are welcome to contact us directly through our website or through our dealer network.
Great. Let's touch on life expectancy of the unit and the warranty that comes with it. And the third part of that would be, does it need any maintenance, or when you update your software, how is that accomplished for the end user?
Sure. Some more great questions. We design our equipment for at least a 10-year lifespan, and we have customers that are still using our legacy FS3DT sonars out in the field. Obviously, they're not as nice as our current products, but they're still operating and functional. The transducer module itself is constructed out of 316 stainless steel, so it is a strong, robust material, and it should last a long time. All of our products come with a standard warranty that's 1 year from installation, 18 months maximum from shipment, but we do offer 24 and 36-month extended warranty options at pretty reasonable prices, because once the equipment's installed and operating, there's really not much that can go wrong with it. As far as maintenance, you do want to clean off the front of the array from the transducer module, clean it from biofouling, just like you do with your Echo Sounder. We have worked closely with Prop Speed to evaluate their relatively new foul-free product, which is a paint-on application for transducers, Echo Sounders, that works great with the FarSounder Forward Looking Sonars. And we have a promotion going on currently. Any FarSounder customer, upon request, we will send a free application kit of foul-free for your first application. It lasts 1 to 2 years, depending on how much you're underway and so forth. So simple maintenance is make sure the array face is clean, whether you're using foul-free or not. If you are someplace that's always operating underway every day, colder water, you might need to only clean the array face once a year. If you have a vessel that mostly sits at the dock in warm tropical water, you might need to clean it once a month. You can just do it snorkeling or scuba diving, just drop down and wipe it off with like a plastic dish scrub or a plastic paint putty knife. As far as other maintenance goes, we offer software updates typically about 3 times a year. Those are free to all of our customers. And if you provide us a contact email address after installation, we will notify you whenever we have software updates available. And we're always working on adding new features, new customer requests, new capabilities through these software updates. And then lastly, the internal maintenance. There's a fan in the computer, there's a fan in the power module. Just make sure it's clean like any other computer on board. Very, very simple, not a lot of work to do to keep these operating well.
Great.
This has been really informative, Matt.
Yeah, thank you. One other person had asked, let me see if I can recall the question. On the website, is there a list of installs and dealers where if people are in a certain region, they can just go to your FarSounder site and find those examples?
Definitely. We have a, in the top menu, if you click on dealers, you'll get a global list that you can search by map or location to find the dealers in that area. If there's an electronics integrator or installer that you regularly work with that's not on that list, please have them contact us. In many cases, we're happy to bring them on board as a new FarSounder dealer. As far as example installations, we have a photo gallery on our website showing installations of all different hull types, all different vessel types, and across our whole product line. So we've tried to show you an example of pretty much every configuration you can think of. If you have a configuration that you don't see there, please ask. We probably have a picture of that. It just might not be as pretty, so we didn't put it on our website. If you go to the main menu, there's an installation menu option, and from there it can bring you to our technical documentation page with the installation design guide and drawing packages for all of our products. We offer complimentary installation drawing review services. So if you're working with the boat builder, the boat yard, and they have a sketch of how they're going to install it, please talk to us. We'd be happy to review the plans. We have a pretty simple checklist in our installation design guide that walks you through the design specifications, but talk to us. We'd be happy to double check everything. Sometimes there'll be a pretty small detail that's missed that's really easy to fix at the beginning, but is hard to fix later on. So please talk to us. And those fairings that we talked about, we don't actually supply those because every hull is a little different, but the fabrication of it is very simple. It's essentially a tube that gets integrated into the hull, and that's typically fabricated by the boatyard.
Good. Jeff,
Great.
thank you.
Thank you so much, Matt and Bob. Is there any other questions that you had come across, Matt, on your side that you saw that we may have not answered correctly or answered completely?
Well, I saw a couple of questions about integration. Someone asked about the Oscar navigation cameras.
Okay.
Very coincidental, we know them quite well. I had a great chat with their CEO, Christoph, and their founder, Raphael, last week in Hamburg at the SMM trade show. We are looking at ways to integrate together and hope to have some things that we can talk about publicly in the general near future. They are a camera system that operates above the water, but they're not just a camera, even though they sell cameras. They really focus on AI algorithms to detect hazards and obstacles and alerts inside the camera image. So like we talked about earlier, radar, camera, charts, and forward-looking sonar are really four navigation technologies that complement each other and work together as a complete navigation picture. Another question about integration was talking about other chart display and ECDIS systems. We integrate directly with the Wärtsilä NACOS ECDIS system. We have a couple of new integration partners that I hope to be announcing later this year, early next year. Some big names like that operating in both the larger trawler yacht, small yacht market, and so forth.
Great.
Well, thank you so much for your time today, Matt and Bob. This was really, really informative to me, and I learned a lot about forward-looking sonar, and I hope our audience did as well.
Well, Jeff, Bob, thanks for taking the time this morning or this afternoon to have this discussion with me. I really appreciate it. For anyone in the audience that has additional questions, please feel free to contact us, through our email, phone. You can just contact info@farsounder.com or through our website, and we'd be happy to answer any other questions that you may have.
And Jeff, thank you, and to Passagemaker for hosting this and setting it up. For people that want to go back and look at this again or want to share this webinar today, where can they find this recording of this presentation?
Sure. Once we get this squared away, it'll live on the Passagemaker website. We'll have a call out somewhere where you could see it and watch this after a few days. It'll be up.
Good. All right.
Great.
Thank you.
All right.
Matt, thank you for all the information. And Jeff, thank you again for